All right, these notes, this video is dealing with notes from section 2.4. We dealt previously with functions. Now we're going to talk specifically about linear functions. And this really, I marked it as a review because none of this is really new. You really, I guess certain aspects of it might be new, but for the most part, this is complete review. All right, so in previous math courses, we're talking probably Algebra 1, maybe a little bit of geometry, but generally in Algebra 1, you use something called the slope-intercept form of the equation of a line, and that was y equals mx plus b. Now, lines generally are functions with the obvious exception of vertical lines. Obviously, the vertical line test fails for a vertical line. And so we will generally, instead of thinking it as y equals mx plus b, we'll think of it as a function, and so we'll call it f of x equals mx plus b. Remember that f of x generally is just y, but since we're thinking of it specifically as a function, we'll use the function notation f of x. Okay. And remember, that means the function's name is f, and the variable used in that function is s, so f of x. All right, m is the slope here, and b is considered the y-intercept. All right, so let's graph each line and give the domain and the range. All right, so if we think about this, they didn't give us an xy coordinate plane, they just give us graph paper here, so let's put in the xy coordinate plane. And let's do our y-axis here. All right, and we're going to label that y, and it's 6. So let's kind of go low a little bit. Our y-intercept is 6. So let's do something like let's call this 6, and then 1, 2, 3, 4, 5, 6. Well, let's just go up 1. So let's do this as our x-axis. We'll call that x. And so then our y-intercept will be 1, 2, 3, 4, 5, 6. And now, so generally for graphing lines, if you remember, we start with the y-intercept and then we use the slope to find other points. So remember that the slope is rise over the run. And so we can think about, we're going to rise up. It's positive, so we're going to rise up 3, 1, 2, 3, and go over 2. So we would have this point here. And then it keeps going, right? It would be off, and we'd be somewhere, let's say up there if we went off. We could also go down 3, which is sort of a negative, and then to the left, which is also negative, and that would give us a positive 3/2 slope. And so again, 1, 2, 3 over 2, go down from this point, 1, 2, 3 over 2, 1, 2, and there's another point. So generally, we want to fill our little piece of graph paper with dots that we know our line goes through, and then sketch in a line, put arrows on either end. All right, so that's a general, just a generic sort of line. Now these are special cases here. So think about f of x equals 2. Again, we need to put in our xy coordinate system here. I'm going to do something maybe like this. That's y and that's x. Here we have a line at f of x is 2. So that, if you think about it, that is going to be what we call a constant function. It is a line, but it's a horizontal line here, up here at 2. All right. And then this last one, C, it's also a special case. I'm going to put my y-axis over here this time. Oop, missed it a little bit there. So call this x, call this y. Kind of went off there a little bit. Okay, that's a little better. And so where will this one be? This is a horizontal line, right? All the y values are the same, 2. This, all the x values are the same at -5. 1, 2, 3, 4, -5. So our line is here. So this line is a vertical line. Of course, this one's not a function. Notice it's not written in this form because it can't be written in that form. Generally think of it as not being a function. This one is a vertical line, okay? When it's x equals, it's vertical. When it's y equals, or in this case f of x equals a value, it's going to be horizontal. All right, so this was one form of an equation, often thought of as the slope-intercept form. Now, going back to thinking of this in standard form, this is the standard form of the equation of a line. We're not using the function notation here. We're using x and y. Again, that's similar to what we do up here. You know, we used x and y because this can be, in this form, it could be a vertical line. So it's not necessarily a function. All right, we want a, our b, and our c, so our two coefficients and our constant. We want them to be integers, and we want them to be relatively prime. That means no common factors. If there was a common factor between a, b, and c, we would divide through by it. Okay, so there should be no common factors, and then there should be no fractions in there. If there are fractions, we'll multiply through by the denominator's value and then clear out that denominator. So, so all three should have no common factors, and we shouldn't have any fractions in there. So they should be integers. Now, some teachers say that your a should not be negative, that it should always be positive. We don't really make that distinction here. You certainly can multiply through by a -1 if you want your leading coefficient of your x here, your coefficient of your x to be positive. You certainly can, but that's not a rule that we generally follow. All right, so, oh, you know what? Forgot to talk about the domain and the range here up here, right? So the domain, let's go back up to A. The domain is all real numbers, so -infinity to infinity. Range, in other words, x. And is there any limit to what x can be? No, x can be anything, right? So there's no limit to the range, the domain, and then the range. Is there any limit to what values, what y values the points on this line can take on? And no, they're also -infinity to infinity. All right, horizontal now. What's the domain? Well, domain can be anything. I can put in any x value. These arrows go on forever. So the domain here is -infinity to infinity, but the range, that's just range value is such that y equals 2. Probably the best way writing that is in interval notation. It's not really possible. So we write that just as y equals 2. All right, and this one is similar. The x can only be one thing. The domain is x equals -5. The range, that one can be anything, goes up and down. So we'll do that one in interval notation, -infinity to +infinity. Okay. So now let's go down to D. Let's graph this function. So a couple ways you can do this. You could think about using intercepts. So like x and y, and you say, well, if I put a 0 in for x, what's my y value? Well, this one works out nicely. If x is 0, that part goes away. I think everybody can see that y would be 3. So that point 0, 3 is on our line. And then if we do the same thing, we put a 0 in for y this time. That part goes away. We have 3x is equal to 12, so that's going to be a 4. So I have 2 points, and generally 2 points is enough to graph the line. So let's see, let's put in our axis maybe here, and maybe here. So we'll call this x, and we'll call this y. And so 0, 3, that would be 1, 2, 3. And then 1, 2, 3, 4, 0. Those are our 2 points. Okay, and you know, we could find like we could figure out like, oh, halfway between would be there. If we just want to like keep doing that, we could say, well, let's see, it's a rise of it's a negative slope of 3/4. So I'm going to go up 3, 1, 2, 3 over 4. So we could do another point here, and I could go down 3 over 4. That would be a point about here, and then you know, sketch in our line. okay? Now, what you could do also is you could take this form of the equation and put it into y equals mx plus b. So I'm going to rewrite this here. So I'm going to take the 3 over, so I get 4y equals negative 3x plus 12. And then I could divide by 4. So y equals negative 3/4 x, and I divide by 4, so that's going to be plus 3. And so then you can see very quickly that I had a y-intercept of 3, a slope of negative 3/4, down 3, which is negative, to the right 4, which is positive. So that slope would be a negative 3/4. Right? And then just keep doing that and getting other points. We could do it that way, or you can do the y-intercepts for that. All right. When is the slope undefined? Slope. So slope is just the difference in the y's divided by the difference in the x's. Doesn't matter if we say y2 minus y1 over x2 minus x1, or if we start with the ones, y1 minus y2 over x1 minus x2. But if you start with point 2, the same point, you have to, end. So in other words, if I start with y2, I need to start with x2. If I start with y1, I need to start with x1. If you flip those, you'll end up getting a sign error. Okay, so this is another way of looking at that. We mentioned it up above, is sort of the rise. So that's the change in the y, is how much you're rising or falling if it's negative. And then the run. We're going to the right if it's positive and to the left if it's negative. So when is the slope undefined? Well, that would be when the bottom, the run, is 0. So that means the 2 points have the same x coordinate. So, of course, when's that going to be? The slope's undefined when our line is vertical, right? And then, 2 points on that line would have the same x. They would be above each other. Vertical line test would fail. So, when is the slope undefined for a line? That is when it's a vertical line. Okay, so vertical lines have slopes that are undefined. All right, let's find the slopes here. So we're just going to use our formula up there. So again, it doesn't matter which point you start with, but whatever point you start with the y, you got to start on the bottom with the same x, right? With the same points x. So let's say negative 6 minus 4 over, this is m. Lowercase m is universally used for the slope. So lowercase m, all right, it's negative 6 minus 4, and then over 2 minus a negative 2. All right, so upstairs we get what? Negative 8, and on the bottom we have 4, and so the slope is negative 2. Wait a minute, no, sorry, that's not 8. I'm not sure how I got 8 there. That's negative 10. All right, so that's going to be not negative 2, but rather we reduce that, of course, negative 5 over 2. Okay. Looking at the next one. In this case, notice there's something interesting about these 2 points. They have the same y coordinate. So if we plug those in, we get 8 minus 8 over, let's say I started with this 8, so I have 5 minus a negative 3. So that's going to be 0 over 8, which is going to be 0. So the slope of 0 means that we have a horizontal line. All right, so slope equals 0 in that case. And if you look at this case, this one's special because the x's are the same. So we're going to have negative 10 minus 10 over negative 4 minus a negative 4. And so that's going to be negative 20 over 0. This is undefined. So we can't really say what the slope is. The slope is undefined. And this results in, this happens from a line that is vertical. So if the line goes through those 2 points are above each other, so the line would have to be vertical. Slope would be undefined. All right, let's go on to page 2 then. On page 2, we're discussing using the idea of slope. for something called average rate of change. So we know that the slope of a line is the ratio of the vertical change in y to the horizontal change in x. Thus, slope gives us an average rate of change in y per unit change in x, when the value of y depends on the value of x. All right, so average rate of change. And we're going to say on some interval, and now this interval is going to be the x value. So when we talk about the interval, we don't talk about y values, but we talk about on the interval of x. So notice it's the change in x, the difference in the x's. It's from a to b. So if we think about this, like we could look at, some curve, and this is out here is A, and out here is B. So we have, a point down here and a point up here, right? So this is the x, and this is f of x, or y. And so we would look at the difference in the y value. So this point B has a y value up here. Point A, the other point has the coordinates A, and then this value down here. So we're looking at the difference in the y values divided by the difference in the x values. And so even though this graph is curved, what we're doing is we are putting a line through those 2 points and looking at what's the difference in the x's, the difference in the y's divided by the difference in the x's. So even though there may be a function going through f of x is a sum function, it may not be a line, it may be a curve, but we're doing the average rate of change through those 2 points. So that would be a line through it. Okay. In 2000, let's do example H. In 2010, the federal government spent $9.5 billion on research in general science. In 2013, they spent $8.7 billion. Find the average rate of change in the amount of the money spent in the research per year. Interpret the results. Okay, so if we think about, let's make just a rough graph here. So you can help visualize this. So in 2010, and then this is 2013. So, and again, this isn't necessarily all to scale. So 9.5 billion is up here, $billion. And then this is 8.7 billion dollars, and that's down here. Now, we don't know how that curve changes. We know at 2013 we're down here at 8.7, and in 2010 we know we're up here at 9.5. Now, we don't know how this graph, how the data is, right? Maybe it's something like that, right? Maybe it changes over time. Who knows? We don't really care. All we care about is the average rate of change difference in the two. So we're looking at how the y's change between those 2 points. We don't care. It could have gone up and back down again. Doesn't matter what's happening in between. All we care about is this point and what's the average rate of change. So what is the change in, remember, this is f of x, and this is x. So the year is the x, and the amount is the f of x. So doesn't really matter what point we pick. Let's pick this one. As essentially our A, and this point as our B if you want. Doesn't really matter. You're going to get the same result either way. So we'll call this one our B. So that means we have 8.7 billion minus 9.5 billion. That's the change in y, so the change in f of x, over the change in, again, I started with 8.7, that's this one, so I got to start with this one, 2013 minus 2010. All right, so if we look, when we subtract these, we'll get negative 0.8 over 3, and so that is our average rate of change. But remember, this is in billions, so let's take So that is in billions of dollars. So let's take our calculators out and divide that, and then we'll convert that to maybe millions per year, the change per year, the average rate of change per year. So again, we don't know what's happening in between. Maybe it's increasing then decreasing, but the average rate of change is simply the slope of that line that goes through those 2 points. And so that would be approximately, it went down, obviously, negative, approximately $267 million. It went down negative, right, per year. Right? Remember, this is a slope. We're not asking how many dollars it went down, but how many it went down per unit of time in this case, right? The x is time or per year, right? So we call it x, but really that is time, right? And then this is f of x, but it's the amount of funding. All right, so between those 2 years of 2010 to 2013, there was an average decrease of $267 million per year. That's what the negative indicates, is that it is a decrease. Don't say a decrease and also a negative, right? So that's how would we sort of, when we say interpret the results, we would say, between the years 2010 and 2013, there was an average decrease of and then $267 million dollars per year. Or if you want, we can do like million and then per year. Okay? All right, so that's how you would sort of interpret that. Sorry, I kind of ran off onto the next question. All right, let's look at I. Given the function f of x equals 2x squared minus 3, find the average rate of change on this interval. So remember, that interval is dealing with the x values. All right, so it might help if we kind of sketch what this looks like, right? So 1, 2, negative 3, and 1, right? So we want to know what's happening between these two, the values of negative 3 to 1 in the x. So if we look, actually what we have to do first is plug in these x values. So we sort of have to give like a two ordered pair. So negative 3, we plug that in. So negative 3, that's going to be what? 18, right? Because that's going to be 9. Negative 3 squared is 9. 18 minus 3, so that's going to be 15. And then let's look at the other point. If we put a 1 in, I get 2 times 1, and that's going to be what? Negative 1. All right. So what's happening is over here at negative 3, I'm way up here at 15, and then at 1, I'm way down here at 1. Let's move this up here so we can see 1, and then our point is at negative 1. So it's right down here. Now, we're not looking at what's happening to this graph, right? We know it's going to be a parabola. We know it's going to sort of, go like this perhaps, right? But we don't care about what's happening in between. All we care about is the average rate of change between those 2 points. So we're looking for basically the slope of that line, okay? And so that's what this gives us. We just, have to find the coordinates. And once we find those coordinates, then we plug them in to our average rate of change formula up here. So we end up with negative 1 minus 15 over, if I started with this, I got to start with this, 1 minus a negative 3. And so that's negative 16 over 4 or -4. All right, so the average rate of change would be -4. Basically, we're asking what's the slope, right? I mean, it's a more sophisticated way of sort of asking, like, what's the slope of the line that would go through the 2 points with these x coordinates? Okay. Let's go on to J then. Assume the cost to produce an item is a linear function and all items produced are sold. The fixed costs, that's $2,400. The variable cost per item is $120. So that's what it costs to make the item. And the item sells for $150. Write a linear function that models the cost, the revenue, and the profit. So let's use c of x for that function, right? The cost in terms of x being the number of items produced and sold. We're going to assume that if we produce it, we are going to sell it. So what would it cost to produce X items? Well, each item costs $120. So that's 120 X. And then the fixed cost, $2,400. All right, the revenue. That's how much we're bringing in. We'll call that R of X. And we sell it for 150. So each item we make, we're going to assume that everything we make, we're going to sell. And so that would be 150x. And then the profit. The profit is simply the difference, right? So the profit we'll call P of x. That's the revenue that you bring in minus the costs. All right, that's the profit. Revenue minus cost is profit. And now we want to look at plugging the things in, right? So let's write what that is. So that's going to be 150x minus, now put in parentheses, so you got to remember to distribute that negative, 120x plus 2,400. And so really it's going to be what? P of x equals 150x, well, let's do it that way one more time. 120x minus 2,400. And so finally, P of x is equal to 30x minus 2,400 is really the profit function, simplified down. All right, and then how many items must be made and sold, because if you make it, you're going to sell it, for the company to make a profit. So we want the P, the profit, to make a profit. That means your profit is going to be positive, right? If your profit is negative, then obviously you're not making a profit. A profit is when this thing is greater than 0, right? So we're going to say 0. We're going to replace the profit as 0, and we want it to be greater. So we want this side to be greater than 0. So we want to think about this inequality. So we want to solve that for x. All right, maybe move the 2,400 over. And then we'll divide by 30, divide by 10, get rid of the zeros, divide by 3. And so that looks like what? 80 is less than x, or x must be greater than 80 for it to be a profit, right? So when you make 80, it seems like it's probably going to be dead even, right? You're not going to lose anything. You're not going to make anything. So if you make anything over 80 will give you an actual profit, which would be something greater than 0. And certainly not negative. Okay. So listed here is the homework. Remember, the multiples of 3 is what those indicate. And that is due next class.